Welcome folks to this demonstration of the effect of large amounts of available nitrogen in the soil on nodulation and nitrogen fixation in a legume plant, in this case pea. So what I've done is I've grown pea plants on a nitrogen deficient soil. Actually, it's a Bradwell sandy loam soil collected from near Saskatoon that had barley growing on it this year and is very low in available nitrogen. The pea plants were seeded about 1 month ago, and we can see here, looking at the two different treatments that I had in terms of available nitrogen. The peas growing here on the soil with no added nitrogen, and a commercial inoculant added to the pea plant seeds, Rhizobium leguminosarium. And over here we have got 200 milligrams of nitrogen per kilogram of soil that was added as fertilizer to this same soil. The pea seeds were inoculated with the same Rhizobium leguminosarium. And we can see here comparing the fertilized, nitrogen fertilized and inoculated pea plants to the pea plants that were had seed inoculant but no nitrogen fertilizer added. You can see that the growth of the pea plants in the two different treatments are very similar. Earlier on, the treatment without the added nitrogen was a little bit slower. It was a little bit shorter in height. But as you can see, once nitrogen fixation began and the nodules established, the treatment without any added nitrogen began to catch up and has nearly approached the growth of the treatment with the added nitrogen fertilizer. So in the case of pulses, little or no starter nitrogen is needed in order to get good growth of a pulse crop typically. What's the effect of the large amounts of available nitrogen added there on nitrogen fixation? Well, that is expressed in the number of nodules that we see on the roots of the pea plants. Folks, you can see on the treatment with 200 milligrams of nitrogen per kilogram of added nitrogen fertilizer, it was added as an ammonium nitrate solution, there are no nodules anywhere on those roots. Those roots are devoid of nodules. In contrast to that, if we look at the roots of the pea plants growing on that soil without any added nitrogen, we can see there large numbers of nodules on those roots. Lots and lots of nodules that are actively fixing nitrogen. So when the soil is low in available nitrogen, as this soil is, and no fertilizer was added, the low availability of nitrogen signals the plant to produce signal molecules that encourage or allow those rhizobium to enter into the roots, and the rhizobium bacterium then to initiate the formation of a nodule, as we see here. And then once that nodule forms, the rhizobium in that nodule becomes active. The plant sends photosynthate carbon down to the rhizobium in that nodule for it to grow, and in exchange, the rhizobium in that nodule fixes atmospheric nitrogen for the plant, and that nitrogen gets sent upward. So it is a symbiotic relationship that establishes when there is low available nitrogen in the soil. If we move over to the treatment here, where we have lots of available nitrogen in the soil, 200 milligrams of N per kilogram added, what happens there essentially is the plant says, hey, there's lots of available nitrogen in this soil. I don't need those rhizobium and the nodules. I don't need to give them any food. So the plant just uses the available nitrogen in the soil. The nodules don't develop. The pea plant does fine, but we don't benefit from the added nitrogen that comes from the nitrogen fixation from the air via the rhizobium in the nodule. So when we've got good nodulation on the roots like this, as we can see here, lots of nodules that are actively fixing nitrogen, and we can tell that by, if we take, let's pull this apart here, they're kind of hard to separate, but if we take those nodules and we take one of them and we cut them open, we can see inside that nodule a beefy red color in the interior of the nodule. And that red color in the interior of the nodule indicates that we have active nitrogen fixation taking place. If the interior of the nodule is white or greenish, that's indicative of a non-active nodule in terms of nitrogen fixation. Folks, the nitrogen fixation that occurs in those nodules will typically allow the legume plant to obtain as much as 70, 80%, sometimes even more, of its nitrogen from the air through biological fixation by the activity of that rhizobium bacteria contained in that nodule on the roots.